This video will show you how to use the redox half reaction method to balance a reduction-oxidation reaction in a basic environment. The very first step is important. It's a thinking step. You have to figure out how to separate this into two half reactions that will allow us to use the half reaction method successfully in all of the remaining steps. This separation is fairly straightforward in this case, as we find one half reaction using tin and the other half reaction using cyanide ion. And now, with that half reaction in place, we can move on to using the process properly. So in this case, we want to start by balancing all of the mass that is not oxygen or hydrogen, and there is nothing to do for either half reaction. The next step is to balance all of the oxygen by adding in water. There's nothing to do here. And in this case, I will have to add in one water molecule as a reactant. Next is balancing mass for hydrogens. Again, nothing to do in the first half reaction. The second half reaction, however, by balancing the oxygens by adding in water, we've thrown our hydrogen balance out of whack. And to fix that, I can add in 2 hydrogen ions as product. Now, the next step we have is to balance charge. And for this, we have to determine where we could put electrons to give both reactant and product sides in the individual half reactions the same value. Here we have +4 and +2. So if I add 2 electrons as reactant, that will satisfy balance. For this half reaction, I have -1 and +2. That is a +1 versus a -1. So to make both sides -1, I can add in 2 electrons. Now, once that step is done, the only thing left to do is what I call the pre-combination. And this is where I look, and this is a thinking step. We verify that our electrons that were added are on the opposite sides. And then we have to figure out a number to multiply each of these by, so that when I combine the entire thing, my total number of electrons will successfully cancel out. In this case, I can simply multiply by 1, because we have 2 electrons on either side, and we can do the recombination. By writing out the result for both half reactions. So my first half reaction, very easy and straightforward. The second half reaction required a little bit more effort, but not very much. So in the recombination step, we want to verify that our multiplication worked correctly by observing that we have the same number of electrons as a reactant and as a product. And those will cancel. At this point, we write out everything we have. And we make one final observation. And that's that in the original reaction given, it's observed that this was done in a basic environment. That means that I have to add in enough hydroxide to neutralize the H+, and I have to add it to both sides in order to guarantee that I maintain balance. Now, in doing this, I can combine the hydrogen ion and hydroxide ion to give me water. This gives me 2 waters compared against the single water. This will cancel, and I will be left with a single molecule of water. So this completes using the redox half reaction method to balance a reduction-oxidation reaction in a basic solution, and it is possible to verify that the salt works out properly.